SKS is a newly released product this year. Therefore, I will focus on introducing the product functions and interface layout to you. Additionally, I will demonstrate the functional characteristics of persistent volume through a simple use case. So here are some features of SKS, so you may briefly understand them. For example, the multiple Kubernetes clusters with different versions, unified management of VMs and containers, flexible cluster expansion and upgrade, abnormal node replacement, performance monitoring and log query. It's worth noting that when used with every root, the network plugin ECP can be used to achieve interconnection between virtual machine networks and pod networks in a flattened manner, and also provide security access controls based on macro segmentation between pods or between pods and virtual machines. When enabling the SKS service on SMTX OS, the first step is to deploy an SKS management cluster. This cluster's only purpose is to create and manage the workload cluster. The workload cluster is the actual Kubernetes environment where your containerized applications are running. So in this environment, we can see we have 3 workload clusters. On this page, the users can easily understand the information of the workload clusters, so such as the virtual IP of the control plane, the number of nodes, the Kubernetes versions, and the resource allocation. Users can also see which plugins are currently enabled and whether they are functioning properly. To enable or disable a specific plugin, simply go to the settings and click the respective button. So here we also have the load balancer, ingress, and the storage CSI plugin. We can easily create a Kubernetes clusters using the graphic interface. So simply fill in the configuration information as promoted on the page. So the first is the basic information, then the node configuration. The last one is the network configuration. Then the SKS will handle the cluster creation with all the specified settings. This eliminates the need for manual operations that can be very tedious and prone to errors. The cluster expansion is very flexible as well. So there are 2 ways to scale. The first, increasing the number of nodes. So under the node group tab, so we can adjust the number of nodes for both control plane and the work nodes. The second way is to scale by creating a new node group. The advantage of using node group is that containerized applications can be classified based on their types and the resource requirements. So for example, the database applications can be deployed on the node group 1, while AI applications that require GPU can be deployed on node group 2. Once the workload cluster is prepared, so it should be provided to the end users for running containerized applications. So for each workload clusters, you will find the download kubeconfig icon. By importing the kubeconfig file into a client that has kubecontrol installed, you will be able to interact with and manage the clusters. next, I will demonstrate how to utilize the persistent volume via command line for a very basic use case. So let's consider the following scenario. We have a busy box pod that needs 5 GB of storage to store the data permanently. The administrator specifies the necessary storage using the persistent volume claim and indicates the storage class responsible for handling the PVC request. This storage class will automatically generate the required persistent volume and send it to the provisioner for processing. I have already downloaded the kubeconfig file on VM04. Let's check it out. Now I can manipulate the workload clusters. This is the YAML file for the persistent volume claim. So here, we define the access mode as the read-write many, the capacity as 5 GB, and the storage class as the SMTX elf as a driver, so which was provided by the SKS by default. After applying the YAML file, the PV will be automatically created. So we can use the command line to check this. Here it is. So you can also view this PV from the interface. It's called PVC Alpha 5. Now, let's create the busybox pod using another YAML file. Here is the contents of the YAML file. So this pod will utilize the persistent volume PVC L5 with the mount point set to elf vol. Afterward, I will make some changes in the pod by creating a new file under the elf vol directory. I will create the pod first. Okay, the pod is ready now. So get into the elf vol directory. Let's create a new file called test. And then I will delete this pod. That's what the file well. It's important to note that the persistent volume is a separate resource object that can store data persistently. So it exists independently of the pod and will not be deleted when the pod is gone. So to demonstrate this, then I will use the same YAML file to create a new BusyBox pod. Okay, still processing. Okay, it's ready now. Let's navigate to the elf_vol directory. See, you will find that the file test still exists. So this entire process illustrates how SKS provides the persistent storage services for the containerized applications. And certainly, if you prefer working with the UI operations, so you can also interact with the interface to create and utilize the persistent volume. Okay, this is all for today's content. I hope today's demo can give you a deeper understanding of our networking and Kubernetes solutions. So feel free to approach me with any further questions after the presentation. Thanks for your time again.